Hey Matthews, this is Mrs. Mounts, and today we are going to learn how to graph quadratic functions. But first, all right, that one's pretty bad. Few holiday jokes here. Good old Santa. All right, let me get my screen set up and we will get going. Okay, so here is your sheet, and this is called a quadratic. Okay, so that's what our new unit is. It's on quadratic functions. And so we've been working on function notation, and so now we are going to apply that and be able to graph these functions. So the first thing that we're going to have to do is find the axis of symmetry. And we get that A and B based on the function that they give us. Okay, so we'll go over that here in just a second. We're going to find the vertex by plugging in that axis of symmetry value. Then we're going to find additional points on the graph, and then we're going to graph those points that we find in the table. Okay, so we'll be referring back to each of these steps here. So here's an example. This is a quadratic function. Notice that it has a squared, and that's what makes it quadratic. Remember, linear, x was to the first power. With exponential, we had that x as the exponent. So now you're going to notice all of these functions are somewhere going to have an x squared value. So the first thing we're going to do is find that axis of symmetry. Well, we're going to label what a, b, and c are based on the function here. So a is going to be equal to what's in front of the x squared term. And sometimes it's an invisible 1. Sometimes it's going to be a different value, but that's what A is. B, what's in front of the x value. That coefficient is 4. And then C is your constant, which is 3. Now, we don't necessarily need 3 for finding the axis of symmetry, but that becomes important later on as parts of the quadratic in the parabola. Okay, so now that we have our A, B, C, our formula is negative B over 2A. So the opposite of B is negative 4. Divided by, the denominator is to take 2 times A. Now 2 times 1 is 2. And then we definitely want to simplify that. That's going to get simplified to negative 2. All right, so that is our x value. Now what we're going to do is we're going to substitute that value in so that we can find the y. That is going to be then our vertex. Okay, so we're on step 2 where it says we are going to find the vertex. We're going to plug in that axis of symmetry value back into the function for x. We'll find the y. All right, so here it is. So we're going to go f of negative 2 equals, we'll put negative 2 in for x. Okay, so I'm just substituting values right here, plus 4 times that negative 2, and then plus 3. Now, some of you may need a calculator. Some of you will be able to do this mentally. Okay, so feel free to do what you need to do to get this solved. I'm going to do it mentally. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. And then add 3. Now you can put plus a negative 8, or I'm just going to keep it minus 8. Now I always like adding those positive values. 4 plus 3 is 7. 7 plus a negative 8 would equal negative 1. And that's going to be my y value. Now notice in the chart there is the letter V. Okay, so that is going to be my vertex. Now I've already solved it. So I'm going to put in -2, and my value for y is -1. Okay, so now what we're going to do is we are going to come up with a couple other data points so that we can plot this. I'm going to go 2 numbers smaller than -2. Okay, so notice it's smaller. So something smaller, if I owe somebody $2, the next I would owe them $3. And then I would owe them $4. And then going down on the chart, I'm getting bigger. Okay, so the next value bigger than -2 would be -1 and then 0. So you always place the vertex right in the middle of the graph. We want 2 numbers or 2 data points that are below and 2 data points that are above. All right, now I'm going to substitute in -4 into our function. So anywhere I see an x, I'm putting -4. Again, feel free to use a calculator. I'll show you how to do that with a calculator. And we just want to quickly get these values. So parenthesis -4, I'm going to square it. That's to the left of 4, or sorry, the left of 7, plus 4, put -4 in parentheses, and then add 3. Okay, and I get a value of 3. And I'm going to put it on the outside. I kind of ran out of room there. I'm just going to go ahead and put it on the outside. So I will eventually plot the point -4, 3. Okay, so now we're going to do that for each of the values. I should have gave a little bit more room for that table. Okay, so I'm going to use my up arrow key, and I'm just going to switch this to 3. And I get 0. Again, now you can pause if you have to. Just practice typing this in, but I love using that up arrow key and just changing my values. I'm going to do it again for -1. So I use my up arrow key. I'm going to change that -3 to -1, and I have to do it in 2 spots. And, oh, I get 0 again. Last one. Oh, 0 is so easy to substitute in. I love that as a value, to be able to substitute in that particular data point. So anything times 0 is 0. Anything times 0 is 0 plus 3. Now, some cool things you're going to notice if in your x we are increasing, decreasing by 1, we're going to get some symmetry here. And that's what happens with the parabola. That's why we have what's called the axis of symmetry. Now I'm going to plot these points. I'm going to go -4, +3, -3, 0. And just do the best you can. I know that didn't maybe turn out the greatest as far as the grid marks. And then I've got -1, 0, and 0, 3. And again, at any point that you need to pause the video, feel free to do that. I'm just plotting these 5 data points. Okay, and then just make a parabola the best you can. We know there's our axis of symmetry. It was at x equals 2, -2. That was our axis of symmetry. This is our vertex, an important point on a parabola. There's our y-intercept, 0, 3. Okay, that's where it's crossing the y-axis. This was the x-axis. Okay, so lots of things now that we can tell about this particular parabola. Okay, now the last thing we are going to do is compare it to the parent function. And how you compare it is really based on the vertex, and if it's opening up, it's opening down. But right now, we're just going to focus on the vertex. Okay, so all we're going to say is that this parabola shifted left and down. That's all we're going to say. We're going to talk about more about the characteristics of a parabola in the days to come. So we're going to say shifted left and down. Okay, and again, that is based on the vertex. Put that in parentheses. That'll just help you. So when you do your worksheet and it asks you to compare, yeah, just check what happened with the vertex. On the parent function, that vertex is at 0, 0. And then we're just looking to see, hey, where that vertex ended up going compared to that parent function.